Building a digital product is complex, demanding, uncertain. And that's where we come in. We're a group of creative thinkers, digital product specialists, dreamers, and team players. With over 15 years in the industry, 400 innovators, 50 awards, building over 150 digital products for our global customers. We engage in your awesome idea and help bring it to life. 99x, creating impactful digital products together. Building a digital product is complex, demanding, uncertain. And that's where we come in. We're a group of creative thinkers, digital product specialists, dreamers, and team players. With over 15 years in the industry, 400 innovators, 50 awards, building over 150 digital products for our global customers. We engage in your awesome idea and help bring it to life. 99x, creating impactful digital products together.
Good evening, everyone, and welcome to day 4 of Quality Week 2023, organized by the Colombo Quality Camp and proudly sponsored by our strategic partner, 99x. Headquarter 99x is one of Asia's best workplaces and a global leader in agile product engineering and technology innovation. We are also pleased to acknowledge our education partner, the Sri Lanka Software Testing Board, a non-profit organization that represents the national industry interest and promotes comprised of a group of experienced experts in software maintenance and promotion of the IS. As always, Quality Week aims to bring industry experts to discuss vital topics that will further enrich your knowledge. A quick heads up, tomorrow marks the training sessions lined up, and we encourage you. Now let's dive into the will be your moderator for the evening. Before we get started, please type in the chat and our speakers will answer them at the end of each session. That said, please join me in welcoming our first speaker for today. Ladies and gentlemen, Sean Navaratna. And software testing manager at Assurity Consulting, New Engineering. Having made SIGAB Technologies, London Stock Exchange 2, Kishan brings a wealth of experience in performance testing. As a committed moderator at the University of Colombo and co-founded the Colombo Selenium Meetup, fostering community knowledge sharing. The master's degree from the University of Bedfordshire, UK, and certifications including ISTQB, Advanced Test Manager, Certified Java Programmer, and Certified Scrum Master, Kishan is well equipped for today's topic. Today, Kishan will guide us through boosting your testing efficiency, offering valuable
Um, Good evening, everyone. Can you hear me?
Yes, we can hear you, Kishan.
Okay, thanks. My dear friends, why do we use a catalyst in chemistry? Now, let's take an example. In the fertilizer industry, if you want to manufacture ammonia, we use iron as a catalyst. So in very simple terms, catalyst will increase the efficiency of a chemical reaction. Now, why do you like to have an energy drink? Because it will provide you an extra boost. So, like a catalyst which increase the efficiency of a chemical reaction, and like an energy drink which gives you a boost, today I'll be taking you through a journey during the next 25 minutes how to boost your testing efficiency with AI tools. So I'm Kishan Navaratne, connecting from Wellington, New Zealand. So when you are going to boost your testing efficiency, mainly I'm going to focus on 3 areas. The first one is going to be on the test strategy. The second one I want to discuss is how we can use AI on test authoring. And finally, I would like to discuss how we can use AI and increase the testing efficiency with test automation. Right, so let's focus on the test strategy. Now, if I want to define a software test strategy, The traditional way that I would have done it, I would have Googled for software test strategy templates. And I would have spent a lot of time going through these documents, doing research, and to find a solution to my problem. Now, this was our traditional way of doing it. But in today's context, it's not like that. So I'm going to use a chatbot. I'm going to use the ChatGPT 3.5. And I'm going to tell the ChatGPT to derive a software test strategy. Right. So the tool will give me the content that I need to include in a software test strategy. So I'm going to do the same thing using the Bard. Yeah, so it will give you the content that you need to include in a test strategy. But this will not help my problem. Because if I want to increase the accuracy and if I want to achieve my overall target, I need to define a proper mechanism to get a better output. So that's where we need to think about the prompts. Now, if you want to define a well-defined prompt, you need to tell the persona, like for any large language model, you need to say how you want to sound it. So that's in simple, persona is the tone that you want to express. The goal, the end result, what you want to have, and the details is for better accuracy, how we are going to tune it, how we are going to get the in details for that. So if you can define your prompts based on the persona, goal, and details, you will be able to get a better output. So let's take the same example and let's try to fine tune it. Now this time what I want is I need an integration test strategy for Salesforce and Workday ERP systems. So in Salesforce, assume that X number of components, and in Workday, Y number of components, I want to integrate it. And for this enterprise level integration, I need to derive a test strategy. So what I'm going to do is, I'm going to tell my bot to define an integration software test strategy, but before you are going to define it, I'm asking to generate about X number of questions so that I can increase the accuracy of the particular result. Yes, so the bot will start generating the questions. So you can see the tool will ask valuable questions. And based on these questions, I can improve the accuracy of the end result. Now, the same thing, what I'm going to do is I'm going to use BARD and I'm going to enter the prompt. But the behavior of BARD is a little bit different. So it will define the test strategy, the general test strategy. And at the end, if you come to the end, it will ask you the questions. So once you answer these questions, you will be able to increase the end result, what you want to achieve. Right, so going back again to ChatGPT. Now, what I'm going to tell is, based on the questions that it raised, I'm going to say my data volume complexity in these two integrations are going to be very high. And I'm going to mention what are the critical components that will be impacted by Salesforce, and what are the critical components that are going to be impacted by Workday. And also what I'm going to do is I'm going to mention the areas about the security. What sort of security restrictions that I want to enforce. So now when I answer those questions and when I give my prompt, the end result seems to be much better, because it will give you the components and what needs to be in the scope. It will give you what needs to be excluded in the scope. So likewise, it will give you a kind of a in detail set of information. Now I'm going to give the same prompt on BARD. And at a very high level, BARD will give you a kind of an output. But then for me, when I compare these two tools, I'm using the ChatGPT 3.5 version. That is the open one. And BARD, for me, my preferred version would be always ChatGPT. Yeah. Right. So the next scenario is when you are defining a test strategy, the most important thing is what are your risks and how are you going to mitigate them? So I want the tool to tell me what are my top 10 risks and how should I mitigate it. So when I give that prompt, you will be able to see that the tool will automatically give me some very good suggestions. Yeah. And also, like, now when you are talking about the risk, you can be very specific. Like, what are the risks that are associated with your test data? Right? What are the risks associated with your test environment? So you can go into detail and you can fine-tune your output. And another very important thing, here is the metrics that I can use in this integration test strategy. So I want to find out what are the metrics that I can include in this integration. So I provide that particular question, and then this will give you a range of metrics that you can include in your test strategy. Yeah. Right. So if you look at it from a very high level overview, when you are defining a test strategy, And when you want to identify the generic content with time, and when you compare it with quality, for you to generate the generic content, it will take only a very short time. And you would have realized that. So if you take this ERP integrations, Salesforce and Workday, I mean, within couple of seconds, you will be able to identify the risks, the main risks that are associated in this particular integration. And also the generic content that is related to the coverage, because otherwise you will have to spend a lot of time on research to identify and to come up with a kind of a coverage, right? And also the generic content that is related to the metrics. So when you actually invest on a test strategy, let's say for you to define a test strategy, it takes about 4 days. But when you use a tool, something like this, sometimes your 4 days of work, you might be able to limit it to 1 to 1.5 days. So especially when it comes to test strategy, risk, coverage, and metrics, like the generic content, you will be able to quickly generate it. And then if you move on to the test authoring, so this is where you are going to define your test, high-level test scenarios. You will try to come up with your test design and your test cases. Now, this is a kind of like a day-to-day activity. So let's see how we can use these type of tools in test authoring. Now, my first scenario is right. So I'm going to take Salesforce and the authentication survey integration. So I want to create high-level test scenarios for Salesforce and the auth server integration. So this will give you a very high-level set of test scenarios, and this will be your starting point. Because if you're doing a kind of like a test design using a mind map, you can use these high-level scenarios to define your parent and your child nodes in a test design like a mind map. And with that, you will be able to expand your test scope, and you will be able to come with a comprehensive test design. So I'm going to give the same prompt in bar. So this will also generate you a set of test cases. The high-level test scenarios. Now, the next scenario that I want to show is how can we generate a behavior-driven development script using these tools, right? So I want to format the above same scenario in BDD format. So I want to generate the Gherkin script. Now, we know that defining a domain-specific language, a DSL, is going to be very challenging because you need to use a particular structure when you are defining a DSL at an enterprise level. But in ChatGPT, it will keep that consistency. So if you want to generate a very high level behavior-driven development scripts, you will be able to get a very high level overview within a couple of seconds. So this is going to be your kickstart. All right. So my next scenario is how can we use to generate a decision table for the authentication scenario. So we know that we have only two conditions. One is for username and the password. So 2 into the power of 2, we should get 4 conditions, and it actually derives those 4 conditions correctly, right? So even if you want to come up with edge conditions like for equivalence partitioning, boundary value analysis, you can ask those questions correctly, and based on your question, you will be able to increase the accuracy. So I gave the same prompt on BART, but here you might see the suggestions are like exhaustive level testing. So that's why I said sometimes the output, when you compare it with ChatGPT, it gives you a kind of a good output in ChatGPT because, yeah. And the other most important thing is we spend a lot of time to create test data. So how can we increase our efficiency by using a simple tool to generate the respective test data? So it will give you a very high level, a set of test data for the above scenario that I was executing. And like if you take, because if you take sometimes like API test cases, for you to automate an API test case, it will take only about 15 to 20 minutes. But for you to generate the test data for the respective API test, you might be spending about 4 to 6 hours. So some of these problems, you can quickly optimize them using these type of tools. Right. And then when we look at the test authoring, especially when it comes to test scenarios, identifying the coverage, and then for different types of testing, you can prioritize your test. You can ask the bot to generate your smoke, regression, and especially exploratory testing. Right? So you need to identify the edge conditions and all those things in exploratory testing. This is a very good tool for you to define those type of testing. So we saw how a decision table was generated. So likewise, you can figure out the different design techniques like equivalence partitioning, boundary value analysis, state transitions, and decision tables. So these type of things you will be able to ask the bot, and you will be able to generate a better output. And also when it comes to test data, these bots will be very helpful for you to generate output. So with that, you will be able to increase the efficiency of test authoring. Right. So finally, the third area that is how can we use these bots in test automation? So for test automation, I'm going to take a very simple application. I'm going to take the web application, the Mercury Tours. I'm going to automate the happy path of registering a new user. So these are the attributes that you need to fill. And once you click on the submit button, you should be able to successfully create a new user. So now what I want to do is I want to generate a Selenium JavaScript for this particular end-to-end scenario. And I'm going to say, okay, you need to come to the home page. From that, you need to navigate to the register page. Right. So you will see this particular script. So we know that like system set property is not a very good practice. Instead of that, what we can do is we can use the WebDriver manager library to handle this type of a situation. So what I'm going to do is I'm going to update this script with WebDriver manager. So it will give me the respective Maven dependency, and also you will see it has updated this particular script. Now at an enterprise level, this script is a throwaway script. But if you are a learner, right? If you want to explore a test automation language, might be Cypress, might be Playwright, any type of things. This is a kind of a kickstart. So what I did was I copied this entire script and I created a Maven project. I just pasted this and I tried to run this program. And you can see the execution. I was able to execute this script without an issue. So in this particular scenario, all the location strategies were 100% correct. And I was able to run my script without an issue. Now, even if I did this, like by going and inspecting these elements, creating this test script, ideally it would have taken about 10 to 15 minutes for me to create this test script. But to come up with this, it would have taken only less than 2 minutes for me to get that working script. But at an enterprise level, we know that this is not a very good practice. So let's see how we can improve this by trying to give different types of prompts. So at an enterprise level, when we are automating applications, we need to adhere, especially when it comes to UI-based applications, we try to adhere to the page object model. The prompt is, I'm going to give a prompt, update the above script based on the page object model. So it will create the home page, it will create the registration page, and finally it will create the test. So without an issue, it will create all the pages. And then we know that WebDriver, setting up the Chrome driver, this is not one of the best practices. So what I want is, I want to have it in a separate place. So what I'm going to do is I'm going to copy this piece of code and I'm going to paste it. And I'm going to tell the tool to make it more generic. Why not you create a test base and optimize this particular solution? And now you can see it has created a separate test base class. So you have your driver in a separate class as a test base. And now when you are writing your test, you can see it has extended the test base. Now in my test, I want to do another optimization. Because if you look at the field registration form, this is where you are entering your test data. Now in this method signature, you have about more than 10 arguments. So if you look at the cyclometric complexity of this particular method, it's going to be very high. And this is not a very good practice. So what I'm going to do is I'm going to tell the tool to optimize this method either by creating a POJO or by using a data provider. Right. So now you can see the POJO has been created. So I have a thing called registration data. So it has successfully created a POJO. And the initial problem that I had, instead of that, it has created a data provider. And inside the data provider, you will see all the data is available. Now, if you want to have this data inside a CSV, if you want to have it inside a Excel, if you want to have it inside a JSON, you can tell the tool how to do it. You can ask the tool, and the tool will give you the required support. Now, in this data provider, what I want is, you can see these data all hard-coded. Instead of that, I would like to get random values. Right. Right. So here, my objective is, I want to get the value, the country, as a random value. Right. So it has created a new class called country util. Now my expectation was to get random values for my as country. So it has created a list with only 3 sets of data. And it has solved my problem. But here, the option is for me, I can get only 3 values for the country. So that is not my expectation. So now what I'm going to do is I'm going to tell the bot, this is not my expectation. Why not you use a third-party library to generate the random values for the country? So let's see how we can do that. Yeah. So I have only 3 predefined values as country. So this is not a kind of a good practice. You don't need to hard code this. So let's see how we can use a third-party library to generate these values. So I'm going to say consider all countries and use a library. Yes. So the bot will say, okay, you can do it by using the Java Faker library. It will give you the Maven dependency also. And you can see how the code has been optimized. Right. So you can do a lot of things. Now, I hope y'all can remember I created a POJO because for the data. So in the POJO, it actually suggested to create setters and getters, but that's not going to be a kind of a very good practice. Instead of that, what you can do is you can use the Lombok package. So let's see how we can do update my script using Lombok. All right, so I'm going to say update the POJO, the registration data that was created by the tool by using Lombok. So it will give me the dependency, and also you can see the refactoring it has done. To the registration data. Right. Now, especially for developers and for test automation engineers, right? So GitHub Copilot is going to be your friend, right? Because for you to do your peer reviews, this tool is going to help you a lot. And if you can use these type of tools, this will increase your testing efficiency a lot. Now, another tool that I want to introduce is Apply Tools. I'm not working for this company, and I'm not a brand ambassador of Apply Tools, but I want to touch this because if you take a UI application and just imagine you do about in that particular end-to-end test scenario, if you have about 5 to 10 test assertions, you have to spend a lot of time to script it. But in this particular tool, it's not something like that. So this is a visual testing tool, and it's powered by AI. So in one go, you will be able to assert everything that will appear on the screen. You might be doing some kind of visual assertions using open source libraries, but then every time the flakiness of those tests is going to be very high, because the moment it exceeds the threshold value, your test will fail. The resolution, the colors, most of those things based on the threshold, if it changes, your test fails. But this tool, it's not something like that. It will increase the testing efficiency a lot, because all those things have been handled by their AI algorithms. Right. But then when we are using these type of tools, you need to be aware about the data sensitivity. Now, this is a kind of a very vital thing, because if you are working on a client project, it's not ethical for you to expose any of the client information on these open platforms, because the data that you will expose, the bots will take it as an input to train their algorithms. So you need to be very responsible. But if you go for the commercial product, they give a kind of a guarantee about the data security, but still you need to get the approval from the organization to use any client particular data. Again, the accuracy. Now, you might be able to get very good results. Sometimes there might be a variation, right? So that's where you need to fine tune your output, your expected results. So when you define, the more you define your prompts correctly based on the persona, the goal, and the details, you will be able to achieve a quality output. And also when you highly depend on these type of tools. So yesterday, so this is a screenshot that I took yesterday. The downtime of this OpenAI platform was about 3 hours, right? Because millions of people are accessing this particular application, and at some time, at a given instance, if you can't scale your application to cater the volume, this is a kind of a risk when you rely on these type of platforms. So the ChatGPT yesterday, the downtime was around closer to 3 hours. Right. So finally, what I want to touch is like a catalyst, right? Like an energy drink. When you bring your human intelligence and when you add with artificial intelligence, you will be able to come up with super intelligence. And when you bring super intelligence into the testing, you will be able to boost your testing efficiency. Right. So with that, I would like to open it for questions.
Ladies and gentlemen, I apologize for any technical difficulties we may have encountered earlier. I trust that my audio is now clear. Thank you for sharing such valuable insights on Quality Week 2023, Kishan. We will now have the Q&A session where you are most welcome to type in your questions in the chat and Kishan will answer them. And I will help in reading out. And we already have a few questions in line, Kishan, and let me pick one for you. And let me read it out for you. When we are automating an application, such as payment app, there are various verification steps like capture, SMS verification, and face authentication during the login and payment processes. As far as I know, there are limitations in Selenium WebDriver that prevent the automation of capture verification. How can we overcome these challenges and automate such an application?
Yes. So there are different ways of tackling this. So there are special libraries that you can use to handle capture. But then when you are automating it in your organization, the easiest way that you can automate it, like let's say you have a one-time password. So you can hard code that particular value as a particular string or something in your test environments, and you can extract that value. And always in your test environments, you will be running it through a particular known value. Because like generating the OTP, generating a captcha, you will be always using third-party libraries. And the third-party libraries, actually, they will assure the quality of that particular product. So in your workflow, it comes as an intermediate thing. So for you, actually, if you go through the particular workflow, when you're automating it, if you have a mechanism to bypass that, so there are different ways that you can discuss with your development team and you will be able to tackle it. I hope I answered that question. So in couple of scenarios, like in my past experience, we did it something like that.
Thank you very much for your answer, Kishan, there. Due to limited time constraints, that's all we can take in Kishan. But you can reach out to Kishan on LinkedIn and drop any question. He will be happy to answer. And also, Kishan, you can answer the questions offline as well while the other sessions are going on. So
Yes.
once again, thank you, Kishan. We are grateful for your impactful contribution to our event.
Right. So thank you very much, everyone. And thank you very much, 99X, for giving me this opportunity. So bye, everyone, and enjoy the rest of the sessions.
And with that, we conclude our initial session for today. As we proceed with Quality Week 2023, let's once again extend our gratitude to our strategic partner, 99X, and education partner, Sri Lanka Software Testing Board, for their invaluable support in making this event possible. With that, let's dive into our second session for the day. Ladies and gentlemen, our next speaker, Yanis Papadakis, brings over 13 years of invaluable experience in QA engineering to our virtual stage. Currently, as the Director of QA at GWI, Yanis plays a pivotal role in crafting testing strategies for their dynamic market research platform. Throughout his career, Yanis has been a relentless advocate for agile methodologies with a particular focus on agile techniques in quality. His passion led him to establish the Athens SDET Meetup, a thriving community where he generously shares his expertise through podcasts, on-site events, and workshops enriching the Greek professional landscape. Yannis's dedication and expertise have not gone unnoticed. He has earned recognition from leading software companies like Grafana and Lambda Test, being part of their esteemed ambassador programs. With a versatile background that includes roles as a test automation architect, QA manager, and software engineer in test, Yannis brings a wealth of diverse perspectives to the table. Today, Yannis Papadakis will guide us through strategies for testing micro front-end applications, leveraging his extensive industry experience. Please join me in extending a warm welcome to Yannis. Over to you.
Hey guys, hi folks. Thank you very much for the nice introduction. I'm going to share my screen. Let me know if everything is okay, so we can start. 1 second. Going to enter full screen. I hope everything is okay from my side. So
Yes.
Thank you for the introduction. I'm Yannis Papadakis. I think you already know a lot of stuff from the presenter. I'm really glad to be here and supporting this conference with my knowledge. So the agenda for the presentation today for me, we're going to do a brief introduction on micro front-end architecture. We're going to discuss next step, the testing strategies. What should we follow when it comes to test a micro front-end? Especially when it's written in React for web development stack. And of course, we'll deep dive on some examples how to do non-functional testing, like performance or accessibility, and summarize and, like, say, generate a more modern testing pyramid based on the needs of the micro-front-end architecture. And we'll close up how everything is, integrating when it comes to continuous integration, how we can do continuous deployments for micro frontends. So let's start with some basic information. See the landscape before going to the micro frontends where we are. A typical architecture is here. We have a single component, which is actually the whole UI monolith. The UI monolith is actually communicating with different microservices on the backend. So you see district, let's say, services that actually integrating with a single UI monolith. So the difference with the microfront is that you are breaking your monolith in different and smaller and manageable deployable units. It's very nice. We're going to see the pros and cons around this methodology. So rather than services providing data which is consumed by the front-end application, they instead provide content in the form of mini applications. So imagine that you have a service A that communicates with a single component of your front-end, or a service B or a service C, like here. So you split the ways of your UI in different parts to accommodate the needs of your backend API services. So let's see some, let's say, advantages or against the UI monolith. Of course, you understand that the design and the development flexibility over here. So the micro-frontend architecture is not tied to a specific particular technology stack. Imagine that if you are building your UI monolith in one architecture and you are using, for example, Vue.js for your UI development, now you can split on different components and different teams can actually use different technology stack because you want to experiment, because you can actually do a lot of, you need to have some freedom around this. The second stuff is you have separate code bases. So you don't have everything tied in a single code base. So you can break down large chunks of code into smaller pieces of code that can be managed separately. Favors native browser over custom APIs. So when developing a web app, it's important to remember that the user's browser will significantly impact how the application is actually experienced. So since micro-frontend architecture relies very hard on the browser, events for communication instead of using APIs. They are pretty simpler to manage and pretty simple to maintain, which is great stuff. You have freedom to innovate. Oh, sorry, guys, one sec. You have freedom to innovate. You can, build yourself with a team. You have independent microservices and micro frontends, so you can pick up any technology, as we said in the first point. Fault seclusion. You can create robust applications, which is very crucial benefit of the micro-frontend design. So meaning that you don't have a risk to affect or produce a bug that affects the whole system or the whole application. It may affect a single part of the application, but not the whole, of course. You can scale fast, so you have faster build time. You can build efficiently more fast single components of your application than building the whole application altogether. Technology agnostic, we said that in the first bullet. We have autonomous teams. They can work isolated. They have their own continuous delivery flow. They can deliver whenever they want their own, let's say, micro-frontend without affecting the other teams as well. And maintainability and reusability. So developers, they are turning to micro-frontend design to break, an extensive program into manageable, let's say, chunks. So you are easily to maintain. It's part of these chunks of programs rather than like have to maintain the whole application each time. And you can reuse parts of the micro-frontends as well. So what are the questions that are rising up, especially when it comes to testing? So the first one is, how do you slice micro-frontends? How do you think what parts of your user interface you are going to slice in order to formulate different micro-frontends? How do you communicate between different micro-frontends? And the part that it's actually caring for us, it's how do you test all of this stuff? So slicing, in my experience, it depends on the teams and actually the behavior of your application. For example, you can have a micro-frontend for your authentication of the user. You can have a separate micro-frontend when you are dealing, for example, in e-commerce and you want to, buy something from the application. So you have a different micro-frontend as well. But this comes the design. How do you slice it? It comes to the decision in the teams. How do they want to actually, let's say, slice it in different manageable components? When it comes to deployment, so this is development workflow, seeing that we are doing test-driven design approach when we are running our micro-frontends on development environment, and then we need to deploy on testing environment before going to production. We have different stages. The good thing is that you can actually deploy each micro-frontend separately without affecting the whole environment, which is testing, staging, or production. So you can actually focus on only and each one of these micro-frontends separately. So you have a sort of isolation when it comes to deploy in a fully integrated environment. And the testing workflow, which is more important for us, we split different layers of testing. We have unit tests when it comes to the React micro frontend. We have integration tests using actually mocking all the dependencies or third-party solutions, or even the backend itself. You can mock and focus on integration tests. You have end-to-end flows as well, acceptance test that needs to be running on staging and production before releasing your micro frontend in a good shape for your customers. When it comes all together, you need a continuous integration and deployment pipeline that consists from functional tests, which is in the left, and from non-functional tests, which comes after you deploy your application. You can run performance tests or accessibility tests directly on your application. I'm hitting here the SLO part on CI/CD because it's really nice to have some metrics around how fast your tests are actually being executed, meaning that you need to have a robust solution that you deploy frequently and you release frequently the micro frontends. So coming to unit testing, we have three main libraries that we used. The React testing library, it's part of the React native support. We have the mock service worker, which is a dependency that you can mock, let's say, your external dependencies to other components. And we have Jest, which is, this is the runner. It's actually running the React testing library unit tests, and it's also producing some metrics around code coverage on your micro frontend. So the problem when it comes to unit testing is you need to write maintainable tests. They need to run fast. They shouldn't bring up browsers. So the React, what you want to do is test the functionality of your React components. So each micro frontend consists of multiple components in React. So that's why we use here a React testing library. It's super fast. It's rendering the components in JS DOM. So it's not opening any browser like Selenium or Cypress. 1 second. Yep. So typically you see the Jest, which is the runner. It's actually executing all these test suites. It's making requests, and MSW, it's actually mocking the response. What the engineering teams are doing, they are providing their own mocks to the tests, and they don't leave the requests happen on your backend. This is super useful when you want to isolate other levels of your architecture, and you want to focus only how functional is your micro frontend without, need to do any backend requests all the time. This is an example here on the right. This is just an example of a unit of an RTL test. You see the test which is running, and it's rendering actually a greeting component. You see that you're directly firing events through JavaScript, and you can actually use the expect library to do some assertions. It's resembles, someone would say that it's like doing UI functional testing, but it's not. It's a separate thing. Now, how do you register MSW? You just use the hooks, the before all, after each all, and after all, to actually start up the MSW server. This is the server that is working as a proxy, intercepting all the requests and giving back specific, like, let's say, fixtures or data that you have developed. Like here, we are pushing like a JSON, which is something specific. It's actually test data. So MSW, good thing, it supports REST APIs, it supports GraphQL APIs, it's doing interception on the network level, so between your client and your server side. It's having native TypeScript support, so teams that are using JavaScript or TypeScript, they are very keen to use MSW as well. And that's it for MSW. Webpack versus Vite. So here is just very quick example of the compiler that you use for your TypeScript or React micro frontends. So Webpack is, the main goal is to take assets of your web projects and bundle them into a small number of files like JavaScript, CSS, HTML, all the assets that the front end of your page is actually consisted of. Vite is doing the same thing, but they serve code locally during development, so you can actually see changes when you're developing your test, which is very nice for the developers. It's actually pretty quick. You can see the timings here. Building a view app or building a whole application with it super fast. You need to have super fast build times to accommodate your continuous delivery of your software. When it comes to integration testing, we see about the unit testing, and you want to test the React components, but you want also to simulate real user interactions, right? You want more end-to-end flows, and you want to test as part of the user perspective. So you have a problem here. We need to have the ability to interact with the DOM and actually make network requests happen, as well as catch visual defects, or you can catch accessibility bugs early on when you're developing your micro frontend. So you think like, RTL is not doing that stuff. You cannot do actual accessibility or visual testing. So you need something else over here. something that comes into the picture, you can use Cypress. We use Cypress. We also, use Playwright in some kind of cases. Both frameworks are doing the same thing. They're actually very nice to debug your testing very quickly. You can run in continuous integration builds. It's super safe and super fast for us to do end-to-end integration testing. Now, when it comes to architecture, because you need some architecture around these tests, what we have done is you need to have the same or similar design to your React micro frontend. So what we did is we split the pages or the React UI components of its micro frontend to page objects that are actually objects incorporate Cypress commands for UI or API. For example, you can do calls for your backend APIs, or you can actually interact with your UI as well. This is an example in the code. Cypress has a way to declare, like in interfaces, your functions. These functions are good because on the top that you can define a business logic or multiple actions you actually simulate on the browser, not actually doing or meaning some. There are meaningful user flows for the user. In the bottom in the right, you see the actual implementation. Why we do that? We create custom Cypress commands. We want to hide Cypress implementation or Cypress details from the user that it's writing or reading a test script. So you have an abstraction layer for that. And this is really nice because you define business operations. Maybe someone that is not so much technical can actually see these tests. And this is an example of the page object. What we do on a page object, which is actually a class. For here, we have a chart page, doesn't matter. We have functions that we, collect the DOM selectors for the UI, and we are mapping them inside these classes. These classes are actually following the React components of the micro frontend because it's, we want to have an analogy. Each component has some set of selectors. These selectors are here for the tests, so you can reuse them from all of your tests. So a typical test resembles like this. You can actually use Cypress API, custom commands, or your page objects. It's even, both approaches can be used. But here you don't see the actual Cypress API calls like, getting an element, clicking on an element. You're actually hiding this functionality on your design. Why use mocks when it comes to Cypress tests? So with MSW, it's good because the developers can actually develop their mock data for you, and MSW works with Cypress and Playwright as well. So you are going to hit like 2 levels of testing at the same time when you're developing your code, both unit and end-to-end. Let's say some metrics. So we develop our test for the micro frontend. We need to have some metrics, like the most valuable metric nowadays. It's code coverage. You need to know how much of your code is being covered from your tests. Thank God we have code coverage support for both RTL and Cypress and Playwright. The only thing you need to do is you need to instrument your micro frontend application code in order to acquire, let's say, to get the Cypress code coverage data. With RTL, you don't need to do that because you don't need to actually deploy your application or your micro frontend in a local environment. So the thing here, I just give an example of a code invite. There are 2 different configuration files. These configuration files, they are being set in order to show how to build your application, to build your micro frontend. So both of them, we are using a library called Istanbul. This library, it's actually instrumenting your source code in order to be ready to review your coverage when you are running your tests. So imagine that your Cypress tests are opening your application, which is instrumented, meaning that each line is instrumented and we are aware from where the tests are actually what are covering in terms of the code base. And this is an example of the coverage. So you see in the right, how many lines of your micro frontend you covered. And in the left, you see the user interface of Cypress. You can actually see how the Cypress is resetting before its test and how we are actually collecting after its test. Of course, there is a library called NYC. This is an NPM package. Just we use it to merge both unit coverage statistics and end-to-end coverage statistics. You need a unified report when it comes to visualize the coverage metrics. Some people saying they want, like the RTL tests, a separate report when it comes to RTL versus Cypress. Most of the time you don't need to have separate reports. You have the same set of tests running as part of the continuous integration pipeline. So you need to merge at some point both of them. So when it comes to non-functional testing, we have visual testing. We have K6. It's a tool to do performance testing from Grafana Labs, and we have accessibility. Now, imagine that these tests are running whenever we commit code. The developer is committing code. He's not deploying any micro frontend yet. So all these tests are running in each commit. So we have super fast shift left testing methodologies applied. Why not build some new non-functional testing around this? So accessibility to incorporate, it's pretty easy. It has a library on top of Cypress. You have already Cypress tests in your pipeline. You build Axe Core, and then you can actually push your metrics as well on Grafana. With this, you can find accessibility violations from your build. It doesn't offer, like Cypress dashboard, a way to have historical data. So what we have done, at least in GWI, we are keeping data on Grafana and Prometheus. So we work together with DevOps to have some observability around how we are doing in regards of accessibility on our platform. So using an example here, this is a script that is running Cypress. You just need to inject your JavaScript. There is a JavaScript file that injects accessibility in your page, and then you can have checks for your accessibility. You can check the whole page, you can check a single element, and run a specific, let's say, rule for your accessibility. It's pretty fast. With just 3 steps, your end-to-end functional test supporting accessibility testing in the pipeline, which is great. When it comes to performance, this is nice because now this is the power of micro-frontend architecture. K6 has a way to measure performance with synthetic testing on the front end. So it can actually capture how fast the application is rendering on any browser. And you can actually split and have different isolation of these tests. Each micro frontend can have its own set of performance tests, which is great, rather having to, integrate your performance tests against the UI monolith, which is super cool, super nice. So we show all of these things. Now, if I want to summarize what we have done is we have unit tests on the bottom layer of the testing pyramid. Mutation tests we didn't cover, but it's a part that you can actually uncover if your tests are finding bugs. It's a nice topic maybe for further discussion in future conferences. Integration testing, we're doing using MSW or before actually, deploying your actual macro frontend to a non-prod environment or production environment. You have the end-to-end test that it's actually testing the whole application with the backend deployed and your frontend as well with the use of the micro frontends. We have accessibility tests, super nice, very quick, just 3 commands, you integrate them. It's a little bit more difficult when you want to build some visualization and observability with Grafana, but building some accessibility tests on top of your Cypress tests, it's pretty straightforward. Visual tests, you can use commercial tools like Apple tools. I think we discussed earlier, the previous presenter, that they are using AI, but you can also use directly Cypress and Playwright have their own, let's say, open source ways to compare screenshots. And we have the performance test in the end. You need to make sure that the functionality is correct for your application. You are accessible you are compliant to the accessibility needs. Visually, you are perfect if you have especially responsive UI and you want to test in multiple devices. Now you need to test the performance, which again, it's something really critical for your application when it comes to to perform well under a huge traffic for the users. If you see the cost is increasing as we go up, maintenance is also really quick to maintain tests when it comes to unit level, to RTL. It's a little bit more difficult when you are increasing. So you need to focus on the pyramid as much as possible, not so many tests in the upper levels, right? So it's very costly for the company, for everybody to maintain this. And in the end, you need to build some SLOs around your release. Meaning SLOs, for us, it takes, we need to codify how the performance in the back and the front end is being done. Especially here, we are keen on the deployment type of its micro front end. We have too many layers of tests. We need to make sure the deployment is super fast. And this is the SLO for us, the time that you deploy your application. So you see here, we are running in a Kubernetes cluster. We can split our Cypress tests, run on multiple workers. You need to make sure you have the best optimization of this part. Each time in each commit, you run both RTL and Cypress. You need to be super, super fast. So you need to have the appropriate resources around this. And this is about the end result. How do we scale Cypress tests? In GitHub Actions, you can set a matrix with containers. Containers means you set a number of actual pods, machines that are running on Kubernetes cluster. Each set of spec files are running on a specific pod in your cluster. And in the end, before concluding, you either maintain your own infrastructure through Kubernetes, or you use a cloud provider like is Lambda Test. But the Lambda Test and any cloud provider, they are more than just maintaining your own infrastructure like browsers, etc. So they have a lot of integration, a lot of features when it comes to the vendor. So conclusion, we saw about micro-frontend architecture today in testing, why it's more efficient when it comes to UI monolith, what type of testing we are having when we are dealing with micro-frontends, why we need also non-functional testing. You need to extend how much efficient your micro-frontends are for the end user, and how to build SLOs, what is a service level objective. Is an agreement and a metric to make sure that you deploy fast your micro frontends to production. That would be all. So sorry for any delay. Thank you very much. And hopefully we have some questions.
Thank you, Giannis, for that insightful session. And now let's kick off our Q&A session. So please type in your questions in the chat if you haven't already, and Giannis will be delighted to provide the answers. And we have a few questions in the chat. Giannis, let me help you by reading them out.
Yes.
We have one question which says, what do you recommend for MFE testing from Cypress and Playwright?
Yeah, it's a typical question when it comes to the browser frameworks. From my experience, both of them are doing great. There are some pros when it comes to Playwright around the sharding, the way that you parallelize your tests. It's out of the box. So with Cypress, You cannot parallelize out of the box. There is an open source solution that some ambassadors of Cypress developed to parallelize tests, but it's not so good. So if you need parallelization, you need to pay for it. So they have Cypress dashboard for that. But when it comes to Playwright, you have the sharding. Of course, parallelization is in the nature of how Playwright executes the tests. So when it comes to optimizing and SLOs, if you remember, you need to make sure you're parallelizing your tests as much as possible. So Playwright has an advantage over there against, let's say, Cypress, what I have seen. Also, the flakiness, in my experience, I've seen that the async and await functionality with the promises that Playwright is built on top of that, it's a little bit better, and we don't, have the same number of flaky tests in our runs on the micro frontend. So this is another factor which slightly makes someone to choose Playwright over Cypress. But this is what the community is talking about. This is my experience as well when it comes to micro frontend. Apart from that, both of them for micro frontend architecture are doing really great to test the end-to-end layer.
Thank you very much, Giannis, for that answer. And we have another question which says,
Sure.
shouldn't we do non-functional testing specifically, performance testing, as early as possible? How can we reduce the cost of finding critical performance issues?
Nice one. Yes, indeed. When it comes to performance testing, think about that it needs time. If it's not part of the development life cycle, what I have seen, when your engineer is committing code and he wants to do it really fast and deploy on a staging environment his, let's say, micro frontend solution, you cannot do that as part of the development cycle. You cannot actually test for performance issues for every commit, because performance testing, it needs time. You need to actually ramp up virtual users. You need to do spike testing or stress testing, which has different type of needs each time. But for example, in general, performance testing needs more time. Someone would say, you are not testing production, right? This is a myth, right? You can find, as the folk here is asking, you can find critical performance issues before deploying to production. This is true. You may not find everything that you have in production, but that's why you need both solutions. You need to run performance tests in a pre-prod environment, maybe on a testing or staging environment, but also on production as well, which it's critical for the real users. Think about staging also, it's not sharing the same resources, right? If you have a staging environment, it doesn't have the same resources. Only if it is a unique replica of production, which is very costly for companies to pay, so much money on G-Cloud to support, let's say, a separate environment clone of production. But running tests on after you deploy micro frontends, it's super critical. I agree with that, 100%. So shift left performance testing as much as you can. Now, if you can, test a little bit your performance needs in the micro frontend when you are developing before deploying the micro frontend, yes, but you need to set clear expectations, like what you are going to test. Are you going to test a full integrated environment because we are using mocks, right? Are you going to test only the web performance, how the micro frontend is rendering, like we saw in the presentation? That's very quick. You don't need to do performance testing, right? For that reason, it's web performance. It's a separate thing. So yes, you can use K6 to do that and measure how fast the micro frontend renders early in the stage of the development cycle. Yep.
Once again, thank you very much for that answer, Giannis. And I hope, due to time constraints, we can take in one more question. Let
Sure.
me read that out for you. When sorting the tests, are you using the original code project in each micro frontends or separate test code? Also, how you organize your integration and E2E tests?
Cool. The tests are stored as part of the micro frontend code base. That's the reason because both quality engineers and front-end engineers are actually coordinating together. We don't want like quality engineers only writing tests when it comes to the micro frontend tests. So what we did is we stored the tests, and we are part of the source code of the actual application, because sometimes you need to put test IDs, for example, on some React components. You don't want to bother the developers. So the quality engineers are getting experience in terms of the code base. So they know how actually the micro frontend is being developed in terms of code base. They can contribute. So they're feeling very nice that they are contributing in the development cycles as well. So no separate test codes. It's part of the code base of each micro frontend. Now, how we organize integration end-to-end tests, mostly what we do is the same set of tests are running against mocks and against the real environment. What we do is just each time we are using a mock instead of a real request to the backend, we are profiling it. So meaning what we are doing, these test data that are provided from the mocks, they are also persisted in a pre-prod environment. So what we do, the same test data that we have for mocks in its micro frontend are also through scripts are persisting on a real end-to-end environment. Why? Because we need the same set of tests running in different layers. Why need to develop two different layers, right? So, and then we're just having a profiler when we are running as part of the micro frontend development or when we are running on pre-prod environment. So don't duplicate yourself. If you want, of course, you can extend your set of tests when it comes to a pre-prod environment, when it comes to user flows that interact with multiple micro frontends. Think about, I need to authenticate, and then I want to the chart page of an e-commerce, which is another micro frontend, and you need to do some stuff. So you cannot do that, in the code base of your micro frontend, right? You should be doing that externally. It's a more end-to-end flow, but these are really limited, right? I think I answered, hopefully, this one.
Once again, thank you very much, Giannis, for that answer. Due to limited time constraints, that we can take in. But there's one more question in the chat as well, Giannis. I hope you can answer that offline during the other sessions are going on. And of course, you can contact him through LinkedIn and get to know if there's anything that you have doubts about. Once again, thank you very much, Giannis, for that expertise, for sharing your expertise and that insightful session.
Thank you very much. Bye-bye.
Thank you very much. That concludes our second insightful session for today. And with that, let's dive in to our third and the final session for the day. Ladies and gentlemen, our final speaker for the day is a seasoned professional dedicated to enhancing test automation efforts and boosting engineers' productivity. Please join me in welcoming Alexander Romanov, a software engineer in test at IOHK with over 12 years of expertise in implementing test automation solutions. Throughout his impressive career, Alexander has made significant contributions to organizations such as Siteco, SoftServe, and Playtika, focusing on making test automation efforts more effective. In his current role at IOHK, Alexander is instrumental in ensuring the scalability and reliability of large blockchain-based solutions. Today, Alexander Romanov will guide us through the intriguing topic of how to test a blockchain. Leveraging his extensive experience in the field, he'll unravel the complexities and share insights into effective testing strategies for blockchain technology. We are privileged to have Alexander with us today, and I'm sure you're all eager to gain valuable insight from his expertise. Without further ado, let's welcome Alexander Romanov. Over to you, Alexander.
Yeah, hello. Thank you so much for introduction. And right now we will start our presentation. And I hope that you are able to see my screen. Yes. Okay. So, can you see the screen?
Yes, we can see the screen.
Okay, good, good. So, yeah, um, let me start my talk with a little bit of personal story. I started to work with a blockchain and blockchain-based applications just like 3 years ago. And when I started to work in the company, I started to dig into and trying to find as much information about blockchains and blockchain testing as possible. But what I saw in the videos on the internet, for example, on the YouTube, it was some kind of information about what blockchain is, but there were really big lack of information on how to test blockchain. So in today's presentation, I want to fill this gap and to help you uh, to be prepared, for example, for your future project, if it will be connected to the blockchain somewhat. So you will be prepared on what is blockchain and what exactly you can use in terms of tools to test the blockchain and its parts. So, what do we see today? We will start with defining what is a blockchain because, in my opinion, we can't test something if we don't understand what we are testing, basically. Then we will move and we will talk a little bit about the essence of the presentation on how can we test a blockchain. And in the conclusion or in the final part, we will talk a little bit about where to start. So what resources do you have, which books or other types of resources you can use to start to dig into the blockchain. So the first is what is a blockchain in itself? Blockchain can be described in different let's say categories in different terms, depending on the like depth that you want to consider. But basically, in order to understand what blockchain is, you need to understand three main things. You need to understand what is distributed system, what is hashing, and what is peer-to-peer communication. So the distributed system. Imagine that, for example, we want to get some honey from some bees. So we can go to the special place where there's bees live, and we get the honey out of the, let's say, out of the um, box where they live. And what we want to have is just honey. We don't know how how their hive is structured, but underneath there are like thousands, tens of thousands, and even more bees that are working on the one particular goal to create a honey. Uh, that we can take as humans. So a distributed system is somewhat similar. So basically, it is like a from user perspective, it is a single system that we can make a request and get some response. But in the on the nutshell, it is basically a connection of like maybe dozens of maybe thousands of nodes that are communicating with each other in order to fulfill a task that you are requesting for. So for example, if you want some data and you call, let's say you are the client one, you make a call and you have a call to node one. Then after the all of the things have been processed, you can get response maybe from node one, maybe from node three, you don't know. So that's the thing that you as a user don't know. So that's the essence of distributed system. For the communication, first of all, I know that many of us that are in the testing world, in the modern testing world, we are working with applications that are, in most cases, built on the client-server model. In this model, we have one server, many clients. It can be web clients, it can be mobile clients, but anyway, we make requests and get responses from the server. But the main thing here is we have only one server and many clients. But there is another type of communication in the systems that exist. It's called peer-to-peer model. In this model, instead of having a single dedicated server and a lot of clients, we have peers. And peer, or the node itself, is one. So it's a client and a server at once. So um, all of the nodes in the peer-to-peer model are on the same level. They are doing their job. They're communicating with each other and providing information to the world. And the last thing is hashing. So hashing is an interesting thing. So if you are doing some kind of automation, you may encounter this hashing in the form of hash maps in Java or some kind of key value pairs in some other languages. But in a nutshell, hash function, it's a special mathematical function that you can provide some kind of information as an input, and as a result you will get a unique, strictly defined in terms of length output. And as you can see, this is like a hash function, so it is a box that do the magic, and depending on the input we will get totally different output. So for example, if you will provide a string test engineering nodes, we will get this output, but if we remove only one letter, we will get totally different output. And the essence of this, and then the main idea of the thing is basically we can use these hash functions as a thing to check whether the message, for example, that we are passing to other party has not been changed. For example, if someone just stole the message and get it updated and send it back, then the hash of this message will be totally different, and it is an indication that something goes wrong. So we have distributed systems, we have hashing, we have peer-to-peer. So the idea of the blockchain is, so it is a connection of the nodes that works as a peer-to-peer that are communicating to each other, but they are like each of the node contains data. And the interesting part on this data is how this data is structured. So the data in the simplest form is a transaction. So for example, the transaction can say that the user A transfers some money to user B. That's a transaction. So as the multiple transactions are just combined into some block and sent, for example, they are combined in node 1, and then they are widespread to others, to other nodes, just to make sure that each node has the same database version. And why the blockchain is because each of the block contains transactions, but also each of the block contains the hash of the previous block. What's the essence and why do we need to do this is because, for example, if some bad actor wants to temper or change transactions in the block 1, then, for example, only one transaction, then the hash of the whole block will be different than it is already defined. So in this particular case, we need to regenerate the block 1, the block 2, and the whole history. So it is very time and resource consuming task. So that's the essence of the blockchain. So it prevents the data from changing, the data for everybody. So that's the main idea of the blockchain, but how can we test and what exactly we can test in the blockchain? So the first, you can test in the blockchains, you can test internals. So what does it mean? It means that we can test, for example, how the nodes passing messages to each other. So the networking layer. We can test, for example, how their nodes are synchronizing data with each other. For example, when it is a new node, then we need to download all the history to this new node. Then we also can test, for example, how the whole system will behave if, for example, half of the nodes will be disconnected from the network. So it is like if we draw, let's say, a line and compare these things to the, for example, to the web application world. So internals, it's like testing operating systems, and the rest is, for example, web applications. So the next thing that you can test in the blockchain, and basically in the blockchain world, it can be various applications of in the form of wallets. So wallets stores your passwords and stores your accounts, and how much, let's say, money you have on one blockchain, on another blockchain, and it can be in different forms. So it can be software-based applications. It can be even hardware, like USB sticks, that the only purpose of it is just store your keys for manipulating your money. Also, in the blockchain world, you can test some kind of exchanges where you can exchange one cryptocurrency to another cryptocurrency. So it's like the simple application with the real money, but in the form of cryptocurrency. So here, if you will test it, so it will be a lot of work on integration of different cryptocurrencies in your system. So it will be a lot of API integration testing here. And the last thing is applications, or decentralized application, or in other words, blockchain-based applications. So it is an applications that do some things, but under the hood, they are working in some way with blockchain. How it looks like? So basically, it can be a web client, it can be mobile client, it can contains a lot of different stuff underneath. So like application business code, but at the same time, it can work with some blockchain using the blockchain API, or we can even store some data on not only like on centralized databases like, let's say, SQL, NoSQL databases, but we can also use decentralized database like IPFS. So what are examples of these blockchain-based applications? One of them is you can test in the form of like decentralized finances. You can work with decentralized IDs. You can have, for example, applications that are basically blockchain-based alternatives to the real-world applications that we use right now. So it can be alternative to the YouTube, to the Instagram, to the Twitter, to the LinkedIn, to any big system. So the difference will be only that the data itself is stored, or the part of the data is stored on the blockchain. And also, when you will test these blockchain-based applications, in some way, you will use the thing that is called smart contracts. So the smart contracts, basically, it is a piece of code that contains some business logic, but this logic is executed on the blockchain itself. There are some different programming languages for it that you can use. So that's also like a big pile of things that you may need to test. Before we move on, I want to highlight a few challenges that you may encounter when you will test the blockchain, and how actually the blockchain differs from the things that we used to work with. So the first thing, you need to have pretty deep technical knowledge to test the blockchain. If you talk about testing blockchain-based applications, when we have basically the same application as we used to, but with API calls to the blockchain, maybe you don't need to have a lot of technical knowledge. But if you are talking about testing the blockchain itself, it requires a lot of technical knowledge on and understanding how this blockchain works, or how these nodes are communicating to each other, and so on. The next thing is, you need to understand that blockchain, in a nutshell, is an unchangeable database. So as soon as you, for example, you write something to this database, then you can't revert it. So it will be stored forever on the blockchain. So for example, if you are dealing with test data, any kind of test data, you need to think about in advance which kind of test data you are using for your tests, because it will be stored. And another thing, it's not only unchangeable database. If you're using public blockchains, it will be also available to everybody. So the careful, be careful with this test data. The next thing, and also it is an interesting thing, that if you are working or your developers are working with the smart contracts, so the piece of code that working on the blockchain, for the execution of the code, you need to pay money, real money. So your developers and you need to be aware each time that if you write not optimized code, so like that, for example, contains some forever cycles like loops or something that is can run forever, then you will be penalized or you will be fined with spending a lot of money, real money. Also, it is like as a blockchain is not like particularly, it's different in a nutshell as our web applications or mobile applications. Approaches to, let's say, for example, performance testing is also different, because we can't just take tools that we used to use, for example, like JMeter or any other tools like K6, and just blindly use the same scenarios as we used to do for the web applications, because the metrics, blockchain performance metrics, are different. So you need to be aware about these things, and it affects also on the processing time. Also, the blockchain world contains a lot of unusual languages, like programming languages and protocols. You need to be aware of it. And right now, blockchain still don't have like a universal tools. Like, for example, for the web, if you learn Selenium WebDriver, then you can test any web application in the world. So that's not true for the blockchain. And the last thing, where you can start right now in the blockchain. First, a quick intro on what do you need to know to test a blockchain, like a theory and practice. So for the theory, you need to be aware, at least aware of the hashing, some parts of cryptography, consensus mechanisms, particular for the blockchains or consensus in the distributed systems, networking. From the API testing point of view, of course, if you know HTTP API testing, it is good, but you need to be aware that a lot of blockchain works on not using HTTP, but using some other protocols like WebSockets, like gRPC or GraphQL. Also, you may learn, for example, the general purpose programming languages like, let's say, Java or JS, or in some cases you can or you should learn or at least able to read some more exotic languages, like, for example, Scala or Rust or Haskell or Go. But in general, if you learn, for example, like a general purpose programming language, I can recommend here like using Python, then you can use tools and you can basically perform a majority of testing in the blockchain. So it, like my advice, go rather with Python or with JavaScript. So this is an overview of the tools that I personally use. For the API testing, I'm using Postman or Insomnia, or in some cases it's simple curl commands. For automation, it's Python and PyTest, and for infrastructure is Docker and AWS. So it's pretty like standard stack, more or less. And the testing tools, and basically the tools for different blockchains, particular blockchains. So I will provide information about one of the three biggest blockchains, but you can find similar tools for different blockchains, because there are, like, right now maybe hundreds of blockchains, like different blockchains available on the market. So the biggest and the coolest thing in the blockchain itself is that many projects, like big projects that you heard of, for example, like Bitcoin, the source code of the Bitcoin is available on the GitHub. It's open source. The same is for tests. So you can go to the GitHub and just check the test for the Bitcoin. So you can really learn how the real system is tested. For the Bitcoin, the tests are, as I remember, it's like on C language, but for the other blockchains, they're written in other languages. Also, it is some tools like Bitcoin G that allows to test Bitcoin node using Java. For the Ethereum blockchain, there are more tools available, starting from coverage tools or the framework like Truffle framework. Also, there are static analysis tools like Mithril and Slither, dynamic analysis tool for example, like Manticore, and some other tools that are not tied to particular language. They are like more general purpose. And the other example of the blockchain that I want to talk about is Cardano. So for Cardano, for example, you can go to the to the GitHub and check this Cardano node tests. So they are written. It is end-to-end tests for the blockchain, and they are written in Python. So you can go and check these tests and see how it's done in the real world. And here are the links. So I will provide presentation or the slides for the presentation after my talk. So you will be able to just go and click on each of the links. So I have a series of blog posts. It's called Blockchain for Test Engineers that you can check. Also, I have a this repository where I'm just collecting all of the resources and white papers on the blockchain testing that you can read and see the examples on how other people test in the blockchain. From the books, we have some of the great books that you can find on the Amazon. And I can recommend a few courses, for example, like blockchain specification. It is on Coursera. And on the Coursera, there is also another specialization is called decentralized finance. So all of these resources are worth of their time. The only thing is, for example, like you can learn like general things about blockchain, and then you can learn a particular. For example, you can concentrate on learning your particular blockchain that you want. Let's say Cardano, Ethereum, like Solana, or any other chains. Conclusions. So what I want to say in the end. First, blockchain, as you may see, is a complex thing. It's pretty complex thing just to understand, and then complex thing to work with. And the more interesting part is that it is not possible to learn everything, like every other thing. Why? Because each of the blockchain contains a lot of like research behind behind them. So there are a lot of scientists that work behind before the blockchain is released. So you need to learn tools, you need to learn how it operates, you need to learn like the how it operates from the business point of view or financial point of view. So it's a huge thing, but it is really interesting. And the last thing is that you need to remember is the blockchain still is evolving. So there are a lot of new advancement in technology. Almost every few months there is a new advancement to the like existing blockchain, or maybe even new systems that are built on top of existing systems, or even starting from scratch. So it is constantly changing and changing its surface. So that's pretty it from my side that I want to talk about today for the blockchain. And right now I can answer your questions if you have some.
Thank you, Alexander, for that illuminating session. Now let's jump into our Q&A segment. Please type your questions in the chat if you haven't already, and Alexander will be more than happy to provide delighted insights. And there's a few questions in the chat, Alexander. Let me read one by one for you.
Mm-hmm.
So the first one we have, it says, do we have a risk in testing blockchain applications using automation because sensitive data is there?
So as for the sensitive data, so of course, when you are testing any blockchain, you have the, let's say, production version of the blockchain, the testnet version of the blockchain that is, let's call it as pre-production version. And in some particular cases, when you are like developing a new blockchain, or even using it, so you can use your locally deployed blockchains. And for locally deployed blockchains, you can use any test data as you want. And for testnet and for the mainnet applications, you should use either just general purpose test data, like something that is not tied to a particular client, or you should, in some cases, if you have sensitive data, you should, let's say, obfuscate this kind of information. Or for example, if you are dealing, or if you want to save data on the blockchain, in some cases you can save not a data itself, but you can save, for example, as I showed you in the presentation, you can save hash of this data. So here, so for example, this data is located on your, let's say, servers, but the hash of the data is translated to, let's say, pre-production. So it is available for everybody. The hash function and the hash of the data is constructed, and it is like the main idea of this mathematical function, that it is really hard to recreate data, original data, by its hash. So it is completely safe, like not 100%, but it is more than safe to save this data on the blockchain, the hash of the data. So that's how we can obfuscate and deal with it.
Thank you very much for that answer, Alexander. Moving on to the second question we have. Could you please mention some of tools that we can use for performance testing of blockchains?
Mm-hmm. For performance testing of the blockchains, it is really interesting, let's say, interesting sphere. There are some tools available. For example, you can use some blockchain-specific tools, like Hyperledger Caliper. It's one, but it is a tool that is created like specifically for Hyperledger projects. There are some of the projects, but it is also adapted to use for Ethereum-based blockchain. Also, as I remember, it is also a tool. It's called White. So I don't remember how it's called. So I will provide the exact answers in the chat and links to these tools. And other things that you can use for the testing blockchains. Basically, if you have an API for your blockchain that is HTTP based, you can use general purpose tools. For example, you can use K6 or JMeter. The only difference is that you need to tune your scenarios in that way that, for example, it is normal to get, let's say, it is normal to get response not instantly. So the measurements are not the same as for web applications, as faster as possible. Because in the blockchain world, the term, let's say, that transaction is confirmed, it means, let's say, that the transaction is added to the one node, and it is spread it to the other participants in the network. And then, for example, we got another blocks, like n blocks on top of the current block, and only after that we can consider that the user can get this final, let's say, confirmation that it is a response. Like if we draw like a comparison with a web world. So we can use basic tools and the same tools as, if you can, of course.
Once again, thank you very much for that answer, Alexander. We have one final question in the chat. Let me read that out for you.
Mm-hmm.
How do you recommend approaching the testing of blockchain functionalities in a testnet environment to ensure a seamless transition and functionality when deployed to the live or mainnet environment?
Mm-hmm. Mm-hmm. So first of all, if you're talking about using testnet environment. So the testnet itself, it's also a big blockchain basically, and it is like publicly available and operated in most cases. So before even moving your code or your blockchain code, or for example, if it is smart contracts, before moving to the testnet, you need to test it locally. For example, in Ethereum, you can run your own node or like a mock node, and you can run your code, your smart contracts against of these locally deployed node. And you can run actually, it will be your first line of testing, like a first level of testing. After you, for example, test every other, let's say, positive and negative scenarios on your local machine. By local, I mean like a particular local machine or your server. I mean like your dedicated server on the, let's say, CI/CD system. Only after that you can deploy to the test net, and then you after you will test or run, let's say, positive tests on the test net, and you make sure that it works in some long term, not only like just let's say correct answers, and you can go. So you need to monitor that it can operate over time, and only after that you can go to the main net. And for the main net, you also need to be aware of this unoptimized code that can actually cost additional money. So that's an answer.
That's all the questions we have for now, Alexander. If you have any additional queries or would like to continue the conversation, don't hesitate to connect with Alexander on LinkedIn. He'll be more than happy to answer your questions and give you more insights. With that, we bring our third and final session for today to a close. Once again, a heartfelt thank you to Alexander for generously sharing his wealth of expertise with us.
Yeah, thanks a lot for your attention, and feel free to just ping me in Twitter or on LinkedIn.
As we draw the curtains on Day 4 of Quality Week 2023, our sincere gratitude goes to our esteemed speakers, Kishan, Giannis, and Alexander, for generously sharing their wealth of knowledge and expertise. A heartfelt thank you to all participants. You've been an outstanding audience, and your engagement has truly made this event special. We are eagerly anticipating tomorrow's sessions, marking the grand finale of Quality Week 2023. Join us as Lahiru Tharaka explores AI-powered test automation, the future of testing. Sparsh Kesari delves into mastering modern web testing with Playwright, and Dilan Varnakula Surya guides us through fortifying your software castle, mastering security design. Before we bid adieu, we kindly request you to take a moment to fill out the survey we've sent to your registered email addresses. Your feedback is invaluable and will help us enhance future Quality Week sessions. With that said, have a wonderful evening, everyone. We look forward to your continued participation in our final session tomorrow. Until then, take care.